Hey guys, so this is the review sheet for the calculus review. Your test is on Friday. This is the third test of the first quarter. Okay, so starting off with the first question, it says the limit as h approaches 0 of x plus h squared minus x squared all over h is equivalent to what? So basically, the first thing you would do is plug in 0 for h. When you plug in 0 for h, you actually get 0 over 0, which is not going to be helpful for us with this problem. So what I'm going to have to do is multiply, FOIL, and reduce to get my answer. So I'm going to first rewrite the limit as h approaches 0. I'm going to rewrite x plus h squared as x plus h times x plus h minus x squared all over h. By the way, this is the definition of the derivative. So basically my goal is to get that h in the denominator to cancel out. I'm going to FOIL this. So foiling it, I'm going to get x squared plus xh plus xh plus h squared minus x squared all over h. The x squareds cancel out, which is nice. What I'm left with is the limit as h approaches 0 of 2xh, because these are the same, plus h squared all over h. Now my h's still haven't canceled out, and if I plug in 0, I still get 0 over 0, so I'm going to have to do a little bit more, and what I'm going to do is factor the numerator. Okay, so if I factor the numerator, I can pull out a GCF of h, so I'm left with h times 2x plus h all over h. The h's cancel out, and now what I have left is the limit as h approaches 0 of 2x plus h. The last thing I need to do is plug in that 0 for h, so I get 2x plus 0, that's just 2x. This is my final answer. Your next question says, evaluate the following limits. Most of these are just all infinity limits. What you have to look for with infinity is think of all your tricks. The same thing over the same thing, for example, the same power would just be the coefficient. So what I'm going to do is look at the first one, and actually that's what the first problem is. The first problem, what you want to do is look for the highest power in the numerator. That's negative 3x squared. Make sure to keep the sign. And the highest power in the denominator. That's 7x squared. Now, see how it has negative infinity here? If I even plug in negative infinity into the squared, it's not going to matter because the squared will make them positive. So what you're left with when you have the same thing, the same power, is just the coefficients. So the rule is basically just use the coefficients when you have a limit approaching infinity and you have the same power on the top and the same power on the bottom, meaning that they are growing at the same pace basically on the top and the bottom. The next question is very similar, except it's a radical question. So what I told you guys to do is look at, first of all, that you have infinity here. You have 11x and radical 2x to the 6th. Rewrite this as 11x over radical 2x to the 3rd, because that's how it comes out. If you plug in infinity here, you should realize that the infinity of the denominator is greater because it's a higher power, so it's heavier on the bottom. So this whole thing is just going to go to 0, be pulled down. Now be careful, if this limit was approaching negative infinity, it would be slightly different, just that you would get a negative, well, you'll be plugging in a negative number. Actually, what I want to do is rewrite this completely. What I'm trying to get at with this problem is, if it was slightly different, you had negative infinity and the numerator was here. Okay, so basically I just flipped it. I'm trying to do a different problem for you guys. So this is not the same one as your review sheet, but it might show you something different. Again, you would utilize the same idea. Take the highest power here and the highest power here. Now you would have radical 2 x cubed over 11x. Now this problem is going to go to infinity because the power on the top is higher. Now this is where people get stuck. If you plug in a negative infinity here and here, it looks like you get a positive infinity. but that's not the case. What you have to do is get your sign from the original. If you plug a negative infinity in here, that even power make it positive, and if you plug negative infinity into here, it makes it negative. So really this problem is negative infinity. The sign comes from the first step, and this x cubed reduction helps with getting the idea of is it heavier on the top or the bottom. Next question, same idea. I have to look for the highest power in the top and the highest power in the bottom because I'm approaching infinity. Remember, these are only tricks for approaching infinity. Okay, so the highest power on the top is 7x to the 9th, and the highest power in the bottom is 3x to the 4th. I have a heavier power in the top and a smaller power in the bottom. So basically I know I'm going to go to infinity, but you have to ask yourself what kind of infinity. I'm approaching negative infinity. My numerator is a odd power, so that means that my whole limit is going to go to negative infinity. Because the denominator is an even power, you plug in a negative thing into an even power, makes it positive, but the top is an odd power, which makes it negative. A negative divided by a positive gets you that negative over here. Alright, next question, same thing. You want to look for the highest power in the top and the highest power in the bottom. You have x squared over x cubed. It's heavier on the bottom, meaning that the whole thing is going to be pulled to 0. Alright, next question. The next two questions you have to utilize that acronym, every pirate likes treasure, which represents the speed of functions. Basically, this stands for exponential. This stands for polynomial. This stands for a log, and this stands for a trig. Exponential is the fastest of all of these, and this just goes down to the slowest. These are basically the strengths of different types of functions. So here's the deal. When you have a fast function over a slow function and you're approaching infinity, you're going to go to infinity, well, positive or negative depending on what kind of infinity, but that's the idea. And if you have a really slow function over a super fast function, that's going to go to 0 because the bottom is faster. So when I look at my first one, I want to say, okay, what kind of function is x squared, which is my numerator? It is a polynomial, okay? Because any polynomial is like x to the third, x to the fourth. My denominator is exponential. Exponential is when you have a variable in your exponent. So that means e to the x is in the exponent, meaning that I'm exponential. So I know that I have p over e. P is slower than e. So I have a slow over fast scenario, meaning that my whole thing is going to go to 0. So that's my limit. Same idea with the next one. I need to think, okay, what type of things do I have? Well, in the numerator, I have a polynomial, and in the denominator, I have a trig function. Polynomial is faster than a trig function, so I have faster over slow. That means I'm going to go to infinity. What kind of infinity? Well, this is a positive infinity. If I plug in a positive infinity to both of these squares, it's still going to be positive, so that's my answer. Next question says, algebraically determine the horizontal asymptotes and the vertical asymptotes. Now, to solve for horizontal asymptotes, you're going to have to find the limit as x approaches infinity of f of x. Find out what that is. And also find the limit as x approaches negative infinity of f of x, because there could be two different horizontal asymptotes, depending on which direction you are going in infinity and negative infinity direction. For vertical asymptotes, we got to do is set the denominator equal to 0. But the first thing you always have to check is if you have holes in your graph. And the way that you check that is you go to your original equation and you have to factor this thing. So I'm going to factor the top with dots and factor the bottom with a GCF. What you realize here is that these cancel, telling me that there is a hole at x equals 2 in the graph. Meaning that when I set this denominator equal to 0, and you end up getting x minus 2 equals 0, and you solve for 2, this is not a vertical asymptote because it's the hole. So really, there is no vertical asymptote because what's left in the denominator is 3. If you set 3 equal to 0, can that ever happen? No. So there is no vertical asymptote for this graph. So what I know right now is that there's a hole at x equals 2 on this graph and there is no vertical asymptote. But what I do need to take care of now is my horizontal asymptote. If I plug infinity into this graph, I'm going to look at the highest power on the top and the bottom. So I end up getting infinity squared over 3 times infinity. That's just going to be infinity, positive infinity, because both things are going to become positive. And the top is also bigger, so I know that I'm going to be growing faster on the top, meaning that I'm going towards infinity. For negative infinity, because I need to check both sides because something could happen in either direction of x, I'm going to plug in negative infinity to the top of my highest power. Again, I'm just curious about these things. And I'm going to plug negative infinity to the denominator, 3 times negative infinity. Well, I know I'm going to go to infinity because I have a higher power in the top. This becomes positive infinity because of the even power, but the bottom makes me a negative infinity because it's an odd power. So I go from infinity to negative infinity. Because I go from infinity to negative infinity as x goes to infinity and as x goes to negative infinity, this is the scenario when you have no horizontal asymptotes. So what I know about this graph is that I have no horizontal asymptote, no vertical asymptote, but I do have a hole at x equals 2. Next question states, find the average rate of change of f of x equals 4 ln of x on this closed interval. Average rate of change's formula is f of b minus f of a all over b minus a. So I'm going to make e a and e squared b. So I'm going to have e squared minus e in my denominator for b minus a. And then for the numerator, I'm going to have 4 ln of e squared, because I'm plugging in the b value, minus 4 ln of e, because I'm plugging in the a value. Now, you should know by now that ln and e cancel to 1, and this cancels to 1 as well. This power is going to multiply with the 4, so I get 8. And this 1 times a positive 4 is, well, a negative 4 is negative 4. So I have e squared minus e on the bottom, combine like terms on the top, so I'm left with 4 over e squared minus e. That's my final answer. Okay, so it's given the function y equals 2x squared plus 3x minus 4. Use the definition of the derivative, find the equation of the tangent line at the x value, x equals 3. So what I want to do first is write my equation of the tangent line, which is the limit as h approaches 0 of f of x plus h minus f of x all over h. And what I'm going to do is plug in first x plus h. So wherever I see an x here, I want to plug in x plus h. So I have 2 times x plus h squared plus 3 times x plus h minus 4. So what I just did is I just filled in this piece. So this piece is done. Minus the second piece, put parentheses around it. The second piece is just the actual function, which is 2x squared plus 3x minus 4 all over h. So now all I gotta do is multiply, distribute, and reduce. So let's take care of all the distributing. X plus h, I can write that twice because it's x plus h squared. I'm going to bring this in with distribution, so plus 3x plus 3h minus 4. I'm also going to bring in this negative, so I have negative 2x squared minus 3x plus 4 all over h. Now I could clean up a few things here. I know that the 4 and this negative 4 are going to cancel. I also know that the 3x and the negative 3x will also cancel, just to make it a little cleaner. So now I'm left with the limit as h approaches 0 of 2 times x plus h times x plus h plus 3h minus 2x squared all over h. What I need to do at this point is I need to FOIL that x plus h times x plus h. So I have the limit as h approaches 0, 2 x squared, xh, and xh make a 2xh, and plus h squared, plus 3h minus 2x squared, all over h. What I'm going to do now is distribute that 2. So the limit as h approaches 0 of 2x squared plus 4xh plus 2h squared plus 3h minus 2x squared all over h. And I can cancel out a few things. This cancels out with this. And what I'm left with is the limit as h approaches 0 of 4xh plus 2h squared plus 3h all over h. Now remember, your goal is to cancel out the h in the denominator, so hopefully you have a GCF in the numerator. And you definitely do. You have a GCF of h. So I can rewrite this as the limit as h approaches 0 of h times 4x plus 2h plus 3 all over h. These h's cancel, so I'm left with the limit as h approaches 0 of 4x plus 2h plus 3. All I got to do now is plug in 0 for h. That becomes 0, and I'm left with 4x plus 3. 4x plus 3 represents your derivative. It also represents the slope at any given point. So this is m. To find my actual value of m, I'm just going to plug in that 2 value that I found. So 4x plus 3 is my equation. My 2 value that they give me is, my x value that they give me is 3. So I'm going to plug in 3 for x, and I get 12 plus 3. That means my slope is 15 at x equals 3. What I want to do now is plug into the equation of a line, mx plus b. I know 2 things so far. I know that m is 15. I also know that my x value, which is what they gave me, is 3. I have 2 unknowns. The only other unknown you can find is the y value. So to find the y value, utilize the original problem, which is f of x. f of x is y. That's 2x squared plus 3x minus 4. This gives you a y value after you plug in x equals 3. So I'm going to have 2 times 3 squared plus 3 times 3 minus 4. So I have 2 times 9 plus 9 minus 4. 18 plus 9 minus 4 gives you a y value of y equals 23. So I'm going to plug in this 23 value into my y, and I'm going to be able to solve for b now. So I get 23 equals 15 times 3, which is 45, plus b. Subtract 45 to solve for b. You end up getting a b value of negative 22. Okay? So I know that y equals 15x. I'm plugging into y equals mx plus b. Y equals 15x minus 22 is one equation I could state. You could also do the point slope formula. So I know that my y value is 23 equals my m value is 15 and my x value was 3. So either equation would work. Alright, I hope this video helped. I'll see you guys tomorrow, and good luck on your test.